Hi there, and thank you for clicking on this video. I have been putting together a series of videos to help you to prepare for the Edexcel Maths A-level exam this summer. This is for the Pure Paper 1, which is on the 7th of June. Here's a list from the exam board of the advanced information topics. Now, the exam board have said that this is the main focus, so there's not too many surprises in the exam, but they've also said that there will be questions where you have to involve skills from other aspects of the syllabus. So you shouldn't just base it completely on this list. There will be synoptic questions where there could be the main focus of the question is these topics, but they could ask you from other areas of the syllabus. So you should be, revising other aspects of the course, not just focusing on these questions. But I've put together a series of videos where I've used the topic tests which the exam board have issued, which they say best align to the type of questions in the exam. And what I've done is used a question from each of the topics to give you some solutions and walk you through. But this shouldn't be your only form of revision. If you're aiming for a top grade, you should be doing lots and lots of past paper questions as well as using this video. So here are the questions that I have done in the same order of the advanced information. This is part 1, so it just goes up to question 8, the differentiation questions. There'll be a part 2 video to go from question 9 to question 14. The exam board have said that the order that they have written the advanced information just follows the order of the syllabus. It's not necessarily going to be the order of the questions in the actual exam, so that's something to bear in mind. Also, can't stress enough that how much you should be testing yourself to see what you would do rather than just watching solutions or reaching for mark schemes. If that question was in front of you in the exam, what would you actually do? That is a skill in itself, just practicing how you would start a question, what sort of ideas, which way does your brain go, how much do you get on the page. Really practice that. Use the description to download the paper copy, the PDF of these questions, have a go at them yourself, or pause the video and see what you would do before you just watch the solution. If during this video you are liking the content and finding it helpful, please do like and subscribe. The more likes means the more people will get to see the video and it can help them as well. Do use the description because there's chapters timestamps within the description, so it can take you directly to a particular topic that you want to look at. And also, I've probably made mistakes along the way, so please do leave some comments. You're welcome to do that as well. Okay, let's get started then. This is my question 1. It says question 16 because it's just taken from the topic test, but it's a proof question using algebra to prove that the square of any natural number is either a multiple of 3 or 1 more than a multiple of 3. Now, normally when you're doing proof questions, you're going to just be bothered whether the number is odd or even. So to make sure it is even, you start with 2n. To make sure it's odd, you have 2n plus 1 or 2n minus 1. But if we're going to start squaring these numbers, they're not going to be able to have a 3 out on the front. So we're not going to be able to use that method here. Because we're wanting to say that it's got to either be a multiple of 3 or 1 more, we'll have to set it up with using a multiple of 3. So if we say that every number can be either 3n plus 1 more than a multiple of 3, or 3n plus 2. Now 3n plus 3 would get us back to a member of the 3 times table. So every natural number could either be written as one of these. That covers all the numbers that are natural numbers. Natural numbers just start at 1 and just do your counting numbers going up. So we need to be squaring these. So 3n all squared is just going to be 9n squared, which is 3 times 3n squared. So this is a multiple of 3. We've taken the 3 out on the front, and then let's try the next one. 3n plus 1 all squared. So that's going to be 9n squared plus 6n plus 1, which is 3. 3n squared plus 2n plus 1, which is 1 more than a multiple of 3. Because we've got that 3 out on the front. And then the next one, 3n plus 2 all squared, will be again 9n squared plus 12n plus 4. And we can write that as 9n squared plus 12n plus 3 plus 1, which is again taking a 3 out, 3n squared plus 4n plus 1 plus 1 again, and this is 1 more than a multiple of 3. So we have shown that all the numbers by exhaustion, because any number can be written either as 3n, 3n plus 1, 3n plus 2. So because we've shown for all cases they are either a multiple of 3 or 1 more, we have shown that every number is either a multiple of 3 or 1 more than a multiple of 3. This is a factor theorem question, and we've got a function in terms of a cubic. So if it had 3 linear factors, then we might write them out, and we know that one of them is x plus 3. So that's going to tell us that x equals minus 3. When we feed that in, then that bracket will equal 0, and it doesn't matter what these brackets are, then we're going to get a 0. So what we need to feed in is f of minus 3. So minus 3 cubed will be minus 27, times 3 will be minus 81, plus minus 3 squared is 9, times 2, so that would be 18a. Minus 3 times minus 4 will be plus 12, plus 5a is going to equal 0. So now we just need to collect all our a's. 18 plus 5 is going to be 23a. Minus 81 plus 12 is minus 69, on the other side is plus 69. So a is going to be 69 divided by 23, which is 3. The next question is about functions and their graphs, but it's also about transformations of graphs. So we've got this modulus graph here, which is 2x minus 3k, and we have to sketch the graph where we've transformed it. It's got a minus in front, and we've also added k. So let's have a look at the original graph to start with. I like to, when I'm doing a mod graph, label each of the two sides of the graph. So when we've got 2x minus 3k, you're told that k is positive, so you're just going to treat this 3k just as if it's a number. So what does this line look like? It's a gradient of 2, and it's a y-intercept, if we carry that on down, of minus 3k. So just treating that y equals mx plus c, and the c is just a 3k. So this part of the branch here on the right is a 2x minus 3k, and because of the mod just reflecting it up, the other side is minus 2x plus 3k. Now I'm going to transform it and do one thing at a time. When there's a couple of transformations going on, I would do one at a time. So the minus in front is going to make it upside down. It's going to do a reflection in the x-axis, so that's going to go like this. Is just going to be the upside down one of this one. And where does that go through? That's going to go through at minus 3k. And what are the names of both of these arms? Well, the one here is just a continuation of that one, so it's minus 2x plus 3k, and then this one obviously is our 2x minus 3k. Now we need to just put a k on the front, and that's going to have the effect of shifting it up k places. So I draw this one, and here this is minus 3k, and I'm going to shift it up 1k place. So it's going to be the same graph, but it's just all going to shift up k place. So this point here where it crosses the y-axis, if it's at minus 3k when we just turned it upside down, we're adding a k on, this will be minus 2k. So you're asked for where it cuts any of the coordinate axes. You're also asked for the maximum point. So the maximum point we're going to work out by looking at this place here, which is here on our original graph, and that is where the 2x minus 3k is equal to 0. So 2x is equal to 3k, so x is equal to 3k over 2, and that is the same place, but it's just been shifted up k places. You can see here it's 3k over 2, 0, the coordinate, but now this place here is going to have its max at 3k over 2, and then shifted it up the y-axis. That will be k high. Now we've just got to work out these two places. Now, if we think of the blue arm and we've shifted it up k, this green on the right is going to be minus 2x, and then we've added a k, so plus 4k, and the green arm on the left is just going to be our 2x. It was minus 3k in blue, but we've shifted it up 1k, so that's minus 2k. Now where that crosses the x-axis is just where both of those are equal to 0. So minus 2x plus, that should be 4k. 4k equals 0, 0, so 4k is equal to 2x. So 2k is equal to x. So that's the point there, 2k. And then the other one is going to be our 2x minus 2k is equal to 0. So 2x is equal to 2k. So x is equal to k. So that's there. So we've got the max at 3k over 2k. We've got the cut to the y-axis at 0 minus 2k. Cuts the x-axis at k, 0 and 2k, 0. Right, so that's just part A, isn't it? Part B. Part B, find in terms of k the set of values where x, where the graph that we've just drawn has to be bigger than x minus k. So if I draw it again so it's a bit clearer, we've got our graph that's looking like this, that's going through there at k, 2k, and that's k, 3k over 2. This is minus 2k. So that's our modulus graph on the left. Where is that bigger than x minus k? Well, if you think of y equals x minus k, it's got the gradient is not as steep as this one that's got a gradient of 2, and the y-axis intercept is minus k. So it's going to go through halfway back towards the origin there at minus k, and it's going to actually go through like that. Y is equal to x minus k, because when that's equal to 0, where does it go through the x-axis? Then it's going to, if you let that equal to 0, it's where x is equal to k, so it's going to go through on that point. So it's where is that straight line going to be below the modulus graph. So we've already can see on the graph that it's going to be for x bigger than k, but what we need to do is work out this point here. So what was the name of this branch here? Was minus 2x plus 4k, and we want to know where does that equal x minus k. So minus 2x plus 4k, where does that equal x minus k? So just have to rearrange. So let's bring this k over, so that will be 5k, and then this over 3x, so 5k over 3 is equal to x. Now it's asking it for in set notation, so it's going to be our curly brackets for set notation, x such that x has to be greater than k but less than 5k over 3. So that will be our set notation. You can write it as x such that x is going to be greater than k, and union that with x such that x has got to be less than 5k over 3. Okay, I'm running out of room here. Part C. Find in terms of k the coordinate of the minimum point of the graph. Well, here we've got our f of x, but it's half x. So when you have a half inside, the effect of this half is going to double all the x coordinates. We're timesing it by -5, which means instead of us having a max here, because of the minus, it's going to reflect back and come back down, and all the y coordinates are going to times by -5, and then finally we're going to shift it 3 places up, so it's all going to have the y coordinates going up by 3. So part C, the max is currently at 3k over 2k. The half is going to double the x coordinates, so the min will be at 6k over 2k, and that's dealing with that half. And then you're going to times it by 5, so that will be times by 5 in the y direction, so that'll be 3k minus 5k, and then finally you're going to add it the 3, and that's going to shift it all up 3, so it'll affect the y coordinate, so it'll be 3k minus 5k plus 3. So that is where the min will go. So this next question is a transformation of graphs question. We're given f of x is equal to this quadratic, and we've got to put it in completed square form. So you can't do completed square with a 2 in the front. So first of all, I would take that 2 out as a factor. Now you just need to take it out on those first 2 terms and just leave the 9 separate and just add that in at the end. So now we're going to complete the square on this bracket, and we need to half the coefficient in front of x. So this is equal to 2, and then we're going to make the square, so half. That will give us, the first 2 terms will also give us a +1, so we need to take off 1. So now we've completed the square, still got our 9 on the end. Now just multiply your 2 in, so it'll be 2x plus 1 all squared minus 2 plus 9, which will be plus 7. So in part B, it's asking us to sketch the curve. So this is all about transformations of graphs. This +1 in the bracket means that the x squared graph has gone 1 to the left, and then this 7 means it's gone 7 up in the y direction, and then this 2 is going to be a stretch, but it's not going to really be involved in sketching it. We're just going to go -1, 7 is going to be our minimum point, so we're going to come down like that, and then the y-axis intercept is going to be at 9. So as long as you've got your minimum point in the right quadrant and you've shown your axes where it cuts the coordinate axes, then that's your sketch is fine like that. Right, part C, we've got g of x as a transformation, and it looks like we have got a -2 here, so that is going to be a shift of 2 to the right. We just need to kind of sort out what's going on with the rest of it. So if we make that transformation in this x term of an x minus 2 and just tried it tidy it up and make it equivalent to what we're being asked about. So minus 2 all squared plus 4. Now we need to make the same transformation, which would be x minus 2, and that would make the whole graph shift 2 to the right, but that's also going to give us a minus 8, so we need to plus 8, and then we'll need to take off our 3, so this will be 2 x minus 2 all squared plus 4 times x minus 2, and then we've got plus 8 minus 3, which would be plus 5. Now these x minus 2's are going to shift the graph 2 to the right, but then this 5 compared to this 9 is going to shift it 4 down. So altogether it's going to be a translation of 2 to the right, 2 and minus 4 down. Okay, that's part 1. Part 2, we're being asked about the range. The range is looking up and down the y-axis, and where does this graph exist? Now we've got the given function f of x now in the denominator, so you're going to be doing 1 over all these points that are in our quadratic. So what's going to be important is this minimum point here, where y is 7. So if we look at 21 over 7, now all the other points, when you do 21 over them, the number on the bottom will be bigger. So when we're dividing by the smallest amount, this is going to be the maximum amount for h of x, which is going to be 3. Now, if you think of this curve, all the values of that denominator are all going to be positive. So the range for this graph is going to be between 0, h of x, and then less than or equal to 3. So this next question is a modelling question, modelling with a quadratic, and it is a max and min type of question. So you're given some information. This golf ball is being hit from a platform that is 3 meters above the ground. The maximum vertical height is when it had travelled 90 meters, so that's going to be there. Its vertical height of 27 after it's been going 120 meters. And that's going to be 27. It's modelled as a quadratic. We've got to find h in terms of x. So h is going to equal ax squared plus bx plus c, and we can see that the y-axis intercept is already 3, so c is going to equal 3. We've just got to find a and b. Now because there's 2 unknowns and we've got some information, it's going to be simultaneous equations to find 2 unknowns. So we've got to use the bits of information that we've got. So here at the max height, dh by dx is equal to 0 when x is equal to 90. So let's find dh by dx. That is going to be 2ax plus b equals 0 when x is equal to 90. So 2 times 90, 180a plus b is equal to 0. So that's one equation. The other equation, we're going to feed in the 120, so x, and the 27 in the h. So at 120, 27, 27 will equal our a times x squared of 120 squared is going to be times 144.00, and then plus 120b plus r3, and then take the 3 over, we'll have 40a plus 120b is equal to 24. Divide by 24, 600a plus 5b is equal to 1. Now if we times this equation by 5, you're going to have 900a plus 5b is equal to 0. Now I've got the coefficients of the b the same. We can solve them simultaneously by taking away. So I do 900 take away 600 is 300a. 5b, take away 5b. The b's are going to be eliminated. 0, take away 1 is -1. So a is going to be -1 over 300. And we would expect our a to be a minus number because we've got that frown rather than the smile. So it's a negative x squared graph. Okay, now all we need to do is find what b is. So I would go into this first equation. So when a is -1 over 300, times it by 180 and see what b is going to be. B comes out to be 3/5. So altogether, h is going to be -1 over 300 x squared plus 3/5 of x plus 3, and that's our h. Okay, part B, find according to the model the maximum height of the ball above the ground. So that's how high this goes. So max height when x is equal to 90. So just feed that in. H is going to be -1 over 300 times 90 squared plus 3/5 of 90 plus 3, and on your calculator that will come out to be 30 meters. Part 2, the horizontal distance traveled by the ball when it hits the ground. So that is finding the whole distance here. So to find these two places here, if we traject this back and find the -1 there, we're just going to use the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to -b, so that's -3/5 plus or minus, and then 3/5 squared minus 4 times a -1 over 300 times c, which is 3, all over -2 over 300. Now when you put all that in your calculator, x comes out to be here -4.86, and that's if we trajected it back to, it's not going to go there because that's not the direction it's been hit, but this one here comes out to be 184.86. So it's saying to the nearest meter, so this is going to be the distance of 185 meters. Part C, the possible effects that could limit the model are wind and air resistance. Give some other limitations. Well, the ball could spin. The ball is not a particle. Or you could have ground unlikely to be exactly horizontal. So you just need to say one of those things to get the 1 mark. Next question is our circle geometry question. We've got a centre 7, 5, so mark that in, and we've got a line that's tangent with equation y equals 2x plus 1, and we are being asked to show that the equation of the line P to A, where its tangent is equal to 2y plus x equal to 17. So if we know that the gradient of the tangent is 2, so the m of the line P to A is going to be -1/2. Now we know the line that we're after is going to go through 7, 5. So all we need to do is y minus y1, which is 5, is equal to m, which is -1/2 into x minus 7. Now I would multiply by 2, 2y minus 10. Take that -1 in, is minus x plus 7. Then just rearrange. 2y plus x is equal to 17, so we've done it. Okay, part B, we're being asked to find the equation for the circle, which is C. So we know it goes through the centre 7, 5, so what we need to do is find out what the how big the radius is. So we know the equation of this line being 2y plus x equal to 17. Where do they meet at P? So we just rearrange this equation to get y by itself. So y will equal minus x over 2 plus 17 over 2. Where does that equal? That's going to intersect y equals 2x plus 1 at P. So if we just make 2x plus 1 equal the minus x over 2 plus 17 over 2. Now I don't like having these fractions, so first thing I would do would be to times by 2. So 4x plus 2 is equal to minus x plus 17. Rearrange. 5x is going to be 15, so x is equal to 3. If x is equal to 3 here at P, then y, we just put 3 into the 2x plus 1. 3 times 2 is 6 and 1 is 7. So the P is the point 37. Now to find the length of the radius, I can see that on here, on the x-axis, this is 4 along, and on the y-axis, this is 2. So the radius is equal to the square root of 4 squared plus 2 squared, which is equal to root 20. And then all I'm going to do is use my equation of a circle, which is x minus 7 all squared plus y minus 5 all squared is equal to r squared, so that's equal to 20. So we found the equation for C. Next part, the line with equation y equals 2x plus k, where k is not equal to 1, so not the same as the given line up here, is also tangent. So it must be this line that's going to come down like this, and we need to find the equation of this line. So we know it's got a gradient of 2, and if I just extend and do the diameter over, then I know if I go down another 2 and across another 5, I can find a point on the line where it's going to be tangent. So if the centre's at 5, if I go down another 2, that will be at 3, and if I go across another 4, that will be at 11. So this point here on the line that we're after has the coordinate 11, 3. So the line we're after is called y equals 2x plus k, and it goes through 11, 3. So I can just feed them in. When y is 3, 2 times 11 is going to be 22 plus k, and then that will give me that k is equal to 3 minus 22, so minus 19. So all we need to do is find the constant k, but the line is y is equal to 2x minus 19, k is equal to minus 19. The next question is just a quick question on arithmetic series. This isn't too difficult a question. So we've got the first term a is equal to 16. The 21st term, well, we use our nth term rule, which is a plus n minus 1 d. So for the 21st term, this is going to be made up of 16 plus 20 lots of d, and you're told in the question that this is 24, so 20d must equal 8, so d is 8 over 20, divide by 4 is 2/5, so d is 0.4. Part B, hence find the sum of the first 500 terms. When you get on the formula book that the sum is equal to n over 2, 2a plus n minus 1 d, and all we need to do is feed in that n is 500. So n over 2, 500 over 2 will be 250. 2a is going to be double 16, which is 32, plus n minus 1, so that'd be 499 times our 2/5. If you put all that in your calculator, you get the answer 57900. This next question is a differentiation question, and we're being given a curve x is equal to 4 sine 2y, and we're being asked to find dy by dx. So because we've got x as the subject, what we need to do first is find dx by dy. Now x has been given as a function of a function. We're taking the sine of double y, so we'll need to use the chain rule. So differentiate with respect that it's sine first, leave alone the 2y, so that will be 4 cos 2y, the 4 will just join in on the front, and then differentiate with respect to the 2y, so that's times by 2, so altogether that will be 8 cos 2y, and then dy by dx will be that upside down, so 1 over 8 cos 2y, and at the origin we have that y is equal to 0, so dy by dx will be 1 over 8 times cos of 0, which is 1, so that will be 1/8. Part B, part 1, use small angle approximations. So when y is small, then y is approximately equal to sine y. So in our equation, x is equal to 4, so sine 2y, we can just do that is going to be times 2y, which is equal to 8y. So the equation x equals to 8y rearranged can be equal to y is 1/8 of x. Because in part 2 we're explaining the relationship between the two answers we've got so far. Dy by dx at the origin was 1/8, so that's the gradient at the origin, and now we've got when y is small, the actual equation of the curve is 1/8 x. So gradient at the origin is 1/8, and equation of curve at origin, because when y is small, is equal to y equals 1/8 x, which also has the same gradient, which has gradient 1/8. So they both have the same results at the origin. Part C, show that for all points then dy by dx is 1 over this function with a's and b's. Well, so far we've got dy by dx and it's containing y, and we want it to find x. So dy by dx so far is 1 over 8 cos 2y. Now we know that sine squared 2y plus cos squared 2y is equal to 1. So if we rearrange that equation and get that cos squared 2y is going to be 1 minus sine squared 2y, and then get cos squared, taking the square root, cos 2y is equal to the square root of 1 minus sine squared 2y. We can go back to our original equation and get that x over 4 is equal to sine 2y. So x squared over 16 is equal to sine squared 2y. So this is going to be 1 over 8 cos 2y is 1 minus, now in terms of x, that's x squared over 16. So this is going to be the same as 1 over 8 times square root of 16 minus x squared all over 16, which is 1 over 8, 16 minus x squared all over 4, and then that 4 can cancel with that 8 and give us 1 over 2 16 minus x squared. So our A is 2 and our B is 16. This next question is a differentiation question. We've got f of x is this curve here in terms of e and sine. Show that the x-coordinates of the turning points. So when we're looking for turning points, we're going to be doing the differential. So fx, we can see that this is a product, so we need to use the product rule. So that is first differential of second, which is cos x, plus second differential of first. Now when you're differentiating e, it will stay the same, but this minus a quarter will come down and times by the 10, so it'll be minus 10 over 4 e to the minus 0.25 x, and then we've got the sine x. So at turning points it's equal to 0 at turning points. And so what we can do is take the 10 e to the minus 0.25 x out as a common factor. You'll have cos x minus a quarter sine x is equal to 0 at the turning point. Now this e function at the front can't equal 0, so it'll have to come from the cos x minus a quarter sine x must equal 0, and then take that to the other side. Cos x is equal to a quarter sine x, and then just cross multiply. 4 is equal to sine x over cos x, which is equal to tan x. So we've shown that it must satisfy tan x is equal to 4. Part B, we've just got this ball that's been kicked and it's going to be bouncing, but it's going to have the same graph as what we've just been dealing with, but in terms of h and t, the height of the ball over time. But these modulus lines means that the graph is going to be all above the x-axis. So we just need to draw the graph, and just instead of it going below, it's going to have its second bounce here, and then its third bounce will be lower again, and then the fourth bounce, and so on. So this will just be our curve. It's just going to go on and on like that. So sketch the graph. The function ht is modelled the height in meters above the ground. Using this model, find the maximum height of the ball above the ground between the first and the second bounce. Well, here's the first bounce, the second bounce is here. Now the maximum points of this graph satisfy this equation where tan x is equal to 4, so that's going to be tan t is equal to 4. So if we say this is going to be tan to the minus 1 of 4 will give us when all these maximums are going to happen. So inverse tan of 4, now you must be in radians, is going to equal 1.3258. Now that will be the first maximum here when we've got the first bounce, but you need to add 180 on, so plus pi for the second bounce, so plus pi, and that will give us 4.47. So the first max will be there 1.33. The next one will be pi later, so 4.47. So we just need to do h of 4.47 and put that in. So that's going to be 10 e to the minus 0.25 times 4.47 sine of 4.47, and when you put that in your calculator, out will come 3.18 meters. So 3 significant figures. Okay, so that's the maximum height on the second bounce. D, explain why this model should not be used to predict the time of each bounce. Well, the height of the bounce is getting smaller and it would not stay at the regular time intervals between each bounce. So as bounce is getting smaller, the time between each bounce will also get smaller. will also get smaller. Well done for getting to the end of the video and watching all the way through all the solutions. Hopefully you found those helpful, so please do add a like and subscribe, and then maybe hit the notification so you'll be notified if I do and put any more videos on. Also, to bear in mind, the grade boundaries this year, the exam board have said, are going to be more in line with the teacher assessed grades. They've said that they will draw some sort of midpoint between where the grade boundaries were at the last exam series when they were actually sat as exams in 2019, and some sort of midpoint between that and how the teacher assessed grades have been awarded for the last 2 years. So the grade boundaries are said that they're going to be generous this year, so that's something else to bear in mind. Okay, good luck with all your revision, and keep an eye out because there'll be part 2 to this video, which will go through the second half of some predicted questions for paper 1.